Today we will be learning about what the terms hydrophilic and hydrophobic mean in the world of science, as well as which substances fall under these two categories. We will learn about the characteristics each one has that makes them this way, and talk about what happens when the substances interact with water. I'll use sucrose, otherwise known as sugars, to talk about what hydrophilic means, and oils and fats to talk about what hydrophobic means. Water is made up of two parts hydrogen and 1 part oxygen. So there is one bond for each hydrogen molecule connecting to the oxygen molecule. Water is a polar covalent bond, which means the electrons within it, shared by the atoms, like to be closer to the oxygen atom than the hydrogen atoms. Think of it as having a favorite parent. It is also a solvent, which means it is a substance that is capable of dissolving other polar substances that are hydrophilic. Hydrophilic, hydro means water, philic means loving, means that when a substance, like sugar, mixes with water, the molecules of the liquid and the solid are attracted to each other. Sugar is made of 6 parts carbon, 12 parts hydrogen, and 6 parts oxygen. Once sugar meets water, the molecules that make up the sweet substance dissolves, and voila! You can't even tell it's been mixed in. And now I'll show you what it looks like when we mix sugar and water together. You can see the sugar is added to the water, the H2O. And we're going to give it a good stir. And the sugar is like, yeah, we love the water, we love the H2O, and it dissolves. This is not the case for hydrophobic substances. Again, hydro means water, but phobic means fear or hating. Have you ever heard someone say, those two go together like oil and water? It means they do not mix. When oil is added to water, it does not dissolve or separate. This means it's hydrophobic. This rings true for lipids, also known as triglycerides. Triglycerides are made from a combination of one molecule of glycerol with 3 fatty acids. Unlike substances that are hydrophilic, those that are hydrophobic are nonpolar, meaning they do not have an electric charge. So when the oils or fats are mixed with water, there is no hydrogen bond formed, and the nonpolar particles clump together to avoid the water. Again, I'll show you, we have water here, and then we have vegetable oil. And I'm going to add it to the H2O, and you can see that there is no dissolving happening here. It all clumps together. I'll show you here. You look at the top, you can see the oil is all clumped together, formed at the top. It does not dissolve. In some cases, there are substances that can be both. Amino acids are perfect examples of this, and I will show you what an amino acid looks like. Ta-da! Amino acids are perfect examples of this. So you'll see here that this is an amino acid is made up of an amino group, a carboxyl group, and then here is the alpha carbon, and then this here is the R group, and this is where the magic happens. Hydrophilic amino acids are either polar and charged or are polar and uncharged. Each amino acid has an amino group on one end and a carboxyl group on the other end. The alpha carbon in the middle has a side chain, that's the R group that I showed you. And some examples of hydrophobic R groups are glycine, alanine, and proline. And I can show you here is another example. Here is leucine. This is hydrophobic. There's leucine. And here is glutamine, and this is a hydrophilic amino acid. The hydrophobic parts of them will fold the molecules so that they can be close to each other and help the proteins acquire their unique shape.